Now let's take a moment to go over the SQLite database server and some of its functionality so that you understand it a little bit better and understand why we're going to be using it in projects for Silicon Dojo and why this is a real useful product that you might be using in the real world. Now the first thing is that this is a full-fledged relational database engine. So you use full-fledged what is called SQL, structured query language, and it is a relational database, so you can do what are called joins, you can have foreign keys, and you can have all that structured query language functionality that you would be used to in most of the other database systems that you would be using. The other thing is that you can have a database up to 281 terabytes in size. Now, I think in one of the previous sessions for this series, I said you could have a database up to 240 terabytes in size. So you might wonder what the difference is here. And basically the difference is the problem that you get to with the database size when it comes to SQLite is not what SQLite as a database system can handle, but it's more what your hard drives can handle. So again, this database, the database that you're going to create and you're going to be interacting with, actually has to be a file within storage. And so the thing is once you get up above 200 terabytes in size, there's a lot of hardware stuff that has to occur to actually make the file itself stable and actually make the ability to interact with that file reliable and that type of thing. And as far as I've been able to tell with research, because frankly I don't have 200 terabytes of storage sitting around, is the issue that you run in with SQLite as far as database size is concerned is not SQLite, but rather what your storage arrays can actually handle. And apparently somewhere north of 240 terabytes, things start to go squirrely. When I was doing this particular slide here, I think they have officially tested up to 281 terabytes in size, but that was, again, that was testing within their particular environment, making sure everything worked properly. So the main thing that I just want you to understand here is that your database can be incredibly large. But again, this is where we start talking about things like the tech stack, like that full technology stack that your project is going to be built on. And the issue that you can run into is not SQLite, but your storage arrays. The next thing about SQLite that I am going to hammer home to you, is that basically this is a single file. It's not basically, it is a single file that you're going to be creating for your database, and you can literally copy and paste that database. It is 100% portable. You can copy and paste it, you can FTP it, you can move that thing however you want, and there's no security on it, not just by default, but actually built into SQLite. There is a way that you can add encryption kind of later. There's like third-party extensions or whatever where you can add encryption and security onto SQLite. But then that kind of begs the question, why the hell are you using SQLite if you start adding security to it? So again, basically when you're using this, this is something that is good for, again, sensor values. This is something good for if you want to track the music that you listen to throughout the day or week or month or that type of thing. This is good for basic log files and that type of stuff. Essentially, if a hacker came in and copied and pasted your entire database somewhere else, would you lose an ounce of sleep over it? And that's going to be one of the things that you need to be thinking about when you're using SQLite. One of the nice things about SQLite, though, with this portability, is it also means you can just copy and paste your entire script. So let's say you have numerous computers. Again, for me, I've got this computer here, and I've got this computer here, and I have 15 computers over there. So let's say I created a script that uses, SQLite as the database, for the records. One of the nice things is I could literally zip my entire script with the database file and then just email it to myself on another system. Or I could airdrop it, to another system, and I could pull it up on that system, all the records and everything would be there. I wouldn't have to worry about security or any of that kind of thing. So that's what we're talking about with the portability. Again, it's either an amazingly wonderful piece of functionality, or a truly horrible piece of functionality, depends on what you're using it for. Now, a big thing that might get you into trouble is the fact is SQLite does not require a data type. And so in a previous session, I was showing you how to use SQLite. We created a table, and we just created a table people, and we just said one column is name and one column is age. And that's it. We didn't say, int, we didn't say character or text, we didn't say float, we didn't say any of that. You can just create the columns and dump values in there. So again, this can be very useful if you know what's going on, and you don't have to worry about anybody managing or maintaining this into the future, because it makes it a lot easier to be able to create tables and be able to automatically start dumping data in. The problem is what happens if in the age column you plug in Bob. What happens, right? You're supposed to put in name and age. What happens if you put in age and name? What would happen when you print out records or that type of thing? So a big thing here, again, either good or bad, does not require data types. Now, one of the weird things with it, though, one of the funny things about it, is you can state what the data type is, though. So when you're creating the table, again, you want to be a good little geek, so you want to type out, right? This is name, so this would be text or a string. This is age, so this should be int or float. This is something else, so this, right? So you type all that in. And so you think you're being a good little geek. Now you know that you won't have any problem with the database. If somebody tries to plug in the wrong value, everything will be okay. Here's the issue with SQLite. If that is all you do, it only takes it as a suggestion. It only takes it as kind of like a memo for that column. So if a coder comes in behind you and they're trying to figure out what type of data is supposed to go into that column, they can look at the schema and they can say, oh, that's supposed to be text, and oh, that's supposed to be a float, and they know what data is supposed to go in. Here's the thing, right? If you have a, let's say age, and you've defined it as a data type of float, and you try to plug in Bob, you will still be able to plug in Bob. It's only a memo. And again, that is a quirk that you can run into. So what you have to do is if you want the data types to be adhered to, so if the wrong type of data goes into a particular column, you have to use what is called strict mode. So I'll show you this in a different session. And so basically with that, when you're creating the table, at the end of it, you append the strict mode at the end. And so what will then happen is somebody tries to put Bob into the age column, then the transaction will fail out, and you'll have that nice good hard fail, so people know there's a problem. So that's one of the things to be thinking about. Data types, is it good? Is it bad? It's just how SQLite deals with things. Now the next quirk with SQLite is you'll notice in the previous session when I created a table, and I've talked about creating a table, right? Create table, people, name, and age. Now again, if you know anything about SQL structured query language, you're probably wondering, wait a minute, what happened to your primary key? Right, so a primary key, every record in a database has to have a value that's absolutely unique. And so that's normally your primary key. It'll normally be like the ID, like so student ID, part ID, vendor ID. Normally what you do is you just make it an int, you auto increment it, so every single time a new record is created, it just goes up in the incrementation. So the first student is ID 1, the second student is ID 2, the third student is ID 3, so on and so forth. There are other ways to do primary keys, but that's the simplest way to deal with it. And so you might be sitting here going, that's weird. You didn't do a primary key. How does that work out? Well, how that works out is actually in the SQLite world, there is a row ID column. So when you do select all, and when I did that previous session, when we did select all, you did not see the row ID. You did not see it. And by default, that's just kind of hidden from you. You can call it, you can request that information, but by default, it's hidden from you. And that is used as the unique identifier. So every time you create a new record, the row ID gets incremented up by 1, and that gives you a unique value. But it wouldn't be SQLite if there wasn't a weird little quirk to it, right? This is not really a primary key, and you do have to be careful with this. So again, if you're taking in sensor values, that type of thing, doesn't matter at all. Might matter, again, if you're creating records for students or parts or inventory control systems. So with that row ID, it does auto increment up, right? So 1, 2, 3, 4, 5, 6. But when you delete a record, so let's say you go through there and you delete, one of the student records or one of the part records, it may or may not reuse that number. So if normally when you create a primary key and you auto increment, even if you delete previous records, basically that primary key will keep incrementing from wherever it's at, and if the original record is gone, the original record is gone, and it just keeps going. The issue here is if you have 1, 2, 3, 4, 5 for records, and you delete record number 3, for row ID at some point it may decide to reuse row ID of 3. Now the issue might be is if you're using that as a unique value to be able to interact with records and you have that stored somewhere else, well, what happens if, in some other database or somewhere else you're referencing record 3, you delete record 3. So normally with a primary key, if you deleted record 3 and then you made a call to record 3, it would fail. You get a nice, good, solid, hard fail, the way the spaghetti monster intended, right? And then there's a problem. Oops, there's a problem. Let me go fix that. Here's the issue you can run into. What if somewhere else calls row ID 3, the original record is there, you delete the original record, SQLite at some point decides to reuse row ID 3, and now when you call row ID 3, you're now calling a different record than you're expecting. So it works. It works. You might not necessarily realize, again, it is what is called a soft fail. It works, but it's not the right information. And then you get to have a bit of a disaster there. So that's what we're talking about with the row ID. And again, things to be thinking about: sensor values, caching systems, that kind of thing. Row ID, probably completely fine. If you're actually creating, again, student records, part records, inventory control systems, anything like that, you still should create a primary key. Now, as I've said a few times before, again, if you want to deal with SQLite, it comes with Python 3, so the easiest way to get SQLite onto your system is by simply installing Python. You go to python.org, you install it. We talked about that in the Python class, yada, yada, yada. So we are on SQLite version 3. That doesn't actually pertain to when we use the command. So when we use SQLite 3, that's actually for the shell. That's not necessarily the version of SQLite that we're using. So the versions, right? There was version 1, I guess way back when. There was version 2, and there was version 3. There is version 3. So version 3, just so you know, came out in 2004. So I am recording this in 2025, so literally it came out 21 years ago as far as my timeline is concerned. I have not heard anything about like version 4 coming out, any of that type of deal, so you should be safe with this. If you run into version 3, or version 2, version 2 was significantly different than 3, much like how Python 2 is different than Python 3. Version 2 of SQLite is different than version 3, but for your own sake, I hope you don't have to run into it in the real world, because that should have died a long time ago. If you find that you're on a system that's using version 2 for some reason, again, keep watching this class so that you know how to use SQL, structured query language, but the rest of it, I don't know how to administer it, I don't know how to maintain it, and frankly, I don't care because it's really old at this point. So that's just one of those with the version things. Again, we've been on version 3 for a long time now. You shouldn't have to worry about version issues. And finally, if you need additional information about SQLite, anything that's not in this class, that type of thing, if you go to SQLite.org, you can go there and there's just a tremendous amount of information about SQLite. Again, this is a very, very powerful database system. You can do a lot of stuff with it. We're not going to go into everything in this particular series of classes, so you can go there to learn more about it. But these are some of the quirks that you might run into with using SQLite. If you're brand new to SQL, you're just going to take this as new stuff that you're learning, no big deal. Again, if you're used to MySQL, MariaDB, Postgres, any of those other things, some of this stuff might throw you for a loop because, again, it's not necessarily the stuff that you're thinking about. You're like, what? What do you mean you don't need a primary key? What do you mean it reuses row IDs? What do you mean you can just simply copy and paste the entire damn database somewhere else, right? Things to be thinking about, especially if you have experience in the database world already.